Today's lesson for matter and chemical change is 3.1, where we are looking at word equations. This whole chapter 3, looks at types of chemical reactions. 3.1 specifically looks at word equations. All right, so all chemical reactions involve changes in elements and compounds. And most chemical compounds have an official name and a common name. So for example, a common name for table salt is salt, but its official name is sodium chloride. And if we go further, sodium chloride also has a chemical formula, which is NaCl. Another example here is bleach. So bleach is the common name, and its official name is sodium hypochlorite. So when we look at word equations, just to do a quick review, it's similar to what we had looked at before, where the reactants are always on the left-hand side of the equation, so left-hand side of the arrow. And then on the right-hand side, we have the products. And plus signs are used to separate the reactants, and plus signs are also used to separate the products. All right, so here we're just looking at that chemical reactions are often represented using word equations. And a word equation, it describes the reactants and the products of a chemical equation using the names of the chemicals. So basically it's using words to indicate what changed during the chemical reaction and what is produced. All right, so here again, we look at this diagram on the bottom. All reactants are there on the left-hand side, then you have the arrow, and then you have all products on the right-hand side. Okay, so make sure there's always an arrow that's separating the reactants and the products, and the arrow is also pointing. The arrow is always pointing towards the products because it's showing that something is being produced during the reaction. And then, like I said, there's a plus sign that's used to separate the reactants, and or if there's more than one product, there's a plus sign used to separate those. For example, reactant 1 plus reactant 2 produces product 1 plus product 2. All right, so here is an example. Limestone caves are formed when the calcium carbonate in the stone combines with acids in the rainwater. The product, calcium hydrogen carbonate, is washed away in water, and it leaves behind these empty caves. So if we look at the reaction, it's the carbonic acid plus the calcium carbonate. Those are the two reactants, and it's producing calcium hydrogen carbonate. So again, when we read this, carbonic acid and calcium carbonate produce calcium hydrogen carbonate. Another way is carbonic acid reacts with calcium carbonate to produce calcium hydrogen carbonate. Here is another example. So this example is converting the food you eat into the energy your body can use. So oxygen and food, the food is represented by glucose, which is the sugar, produces carbon dioxide, water, and energy. So if we look at our reactants, our reactant is the oxygen plus the glucose, and together, when they react, it produces carbon dioxide, water, and energy. So there's 3 products on the right-hand side. And again, plus signs are used to separate the products. All right, so this is what's happening during cellular respiration. The glucose, which is our food, it's broken down into water, carbon dioxide, and energy so that cells can use that as a source of energy. Okay, here's another example. Adding hydrochloric acid to mossy zinc. So if you did this reaction, if you added hydrochloric acid to mossy zinc, the solution became warmer as the zinc dissolved and a gas was released. So first of all, those are just some indications that a chemical reaction has occurred. And then if we write out our word equation here, it's zinc reacts with hydrochloric acid and it produces zinc chloride, hydrogen gas, and energy. All right, so today's lesson for 3.1, you're working on page 43, question 1, it's A, B, and C.